For middle school students, solving fraction problems often means memorizing and applying procedures to a collection of numbers on a page, without students really understanding what's going on with those numbers. We want our students to be able to use fraction computation procedures, such as cross-multiplying or finding a common denominator. But we also want them to have a strong conceptual understanding of fractions, meaning that they understand what these fractions are, where they belong on a number line, and how they can be used to solve problems involving addition, subtraction, multiplication, and division. We use fractions in almost every aspect of our lives, so supporting students to develop a strong conceptual understanding of fractions and fraction computation will help them become successful in both higher-level mathematics courses and many careers. So what does instruction look like when students are developing their conceptual understanding of fraction computation? We might see them depicting and working on a fraction division problem in a real-world context. Or we might see the whole class discussing a real-life example of fraction division shown at the front of the room. We'll see students working together, communicating about the mathematics, gesturing and describing the visual representations, and explaining the steps they took to solve a problem. For example, with a problem that asks, how many people can we serve with 5 cups of orange juice if we give each person 3/5 of a cup? Instead of saying, oh, well, invert and multiply, students with a conceptual understanding of this problem can depict the situation visually, and they can describe the different fractions involved at each step of the problem. They can also judge the reasonableness of their solution, understanding that even though they're dividing, they'll actually be able to serve more than 5 people, because they're giving each person only a fraction of a cup. As they solve the problem, students can answer questions such as, can you show me in your diagram why you have more parts than you started with? Or, how do you know you'll have enough orange juice for everyone in the class? And what does the 1/3 that we have left over represent? Okay, so how do we support students with this conceptual understanding and with engaging in fraction computation in these ways? Visual representations are one key way to do so. Using visual representations builds a stronger foundation for a conceptual understanding of fractions and fraction computations. Visual representations also can help address common and often persistent misconceptions. For example, students may try to add denominators and add numerators. Or they may think that dividing fractions will give a smaller answer, because their prior experience dividing groups by a whole number gave them smaller amounts. On the other hand, when students get comfortable with visual representations and concrete models, their use of those representations gives them visual information about the fractions that can support them in confronting their misconceptions and in recognizing errors. For example, students can tell whether an answer they found is reasonable and whether it should be bigger or smaller than the number they started with. They can visualize how adding 1/2 and 1/2 can't give you 2/4 or 1/2, and they can see how dividing 1/2 by 1/4 is 2, because there are 2 1/4 in 1/2. Having a variety of real-world examples and visual representations will greatly support students' conceptual understanding of fraction computation, and it will provide them with a crucial foundation for later success in higher-level mathematics courses and real-life applications. In this practice guide and toolkit, you will find many evidence-based strategies and tools to help your students use visual representations to build meaning behind the procedures we use to solve problems involving fractions.